Ubiquiti had added the BGP support to UDM Pro for a while, but I still haven't made a video about BGP yet. The reason is I have been waiting for my UCG Pro to receive the firmware update to support BGP. But as of today, you can see on the screen, I'm showing you 3 UniFi routers. The UDM Pro, yes, it supports BGP. The EFG, yes, it supports BGP. But for UCG Pro, even though it has the exact same network application version, it simply doesn't have BGP here. I don't want to wait anymore. I decided to make a BGP video using EFG and UDM Pro. By the way, from day one I purchased this UCG Pro, I had a concern, which is it only has 2 GB of memory, only half of what UDM Pro has. To purchase a UCG Pro instead of a UDM Pro, you are paying more to get a lesser hardware. It's not fair, but that's how these 2 devices are priced. And now I have to guess for UCG Pro, it's so difficult to add BGP support. Is it because of memory? I don't know, but that's the only thing I can think of. There are 2 different types of gateway protocol. One is EGP, Exterior Gateway Protocol. It is used between AS, Autonomous Systems. And another type is IGP, Interior Gateway Protocol. IGP is used between gateways within an AS, Autonomous System. So for example, within one corporate, you use IGP to exchange routing information among your gateways. But between 2 corporates, you use EGP to exchange routing information. And BGP is short for Border Gateway Protocol. It's a standardized EGP. It is used to exchange routing and reachability information among AS on the internet. Apparently, with more ambitious goals from Ubiquiti to enter the enterprise market, BGP is becoming more and more important. This is my lab environment. I have a UniFi gateway which is connected to internet. Behind this gateway, I run a lab environment. I'm going to simulate 2 autonomous systems, and for each AS, I only have 1 gateway. Just to simplify this video, I'm going to use UDM Pro in AS1, EFG in AS2, and then I'm going to use BGP to establish connections between the VLANs from AS1 and AS2. Just to understand the communications between the 2 autonomous systems, I'm going to run Wireshark to capture the packets. I'm going to start from scratch, configuring the BGP. During the process, you will see the very primitive implementation from Ubiquiti to support BGP, and you will be surprised to see the role of firewall policies. And then in the second part of the video, I'm going to dig deeper. Let's try to understand line by line in the configuration files to establish the BGP. And we will SSH into the 2 gateways to see how BGP is implemented using the FRR, the real hero behind the BGP support for Ubiquiti gateway. Okay, let's get started. Let's first take a look at the user interface for BGP configuration in UniFi Gateway. For this UDM Pro, if I go to Settings, under Policy Engine, click on BGP, what you see first is this ridiculously simple UI. You may think, wow, perfect. For such a complicated protocol configuration, Ubiquiti can implement it using such simple UI. It's must because Ubiquiti greatly simplified the configuration, right? No, it's not the case. What you can do is here, choose the device. For this case, it's only UDM Pro. And then what you are left, you need to upload a file. So all the complication is behind this file. You need to manually provide a configuration file. So then what's the point of the UI? Why not simply go to the backend, configure FRR, right? I'm not super happy about this UI. But anyway, let me proceed. Here comes my second complaint. So let's say here I have a dummy configuration file. You can see the size is 0 bytes. If I pick this one, at least it gives me a warning, right? But let me open the file, type several random lines, then save. Here, let me try again, delete it, upload again, choose this dummy file. See, no warning. The only thing the UI checks is the file shouldn't be 0 byte size. That's it. If I continue, edit, once you configured the BGP, you can only see whether it's enabled or not. It doesn't tell you whether it's really running. You cannot get any metrics, any statistics, any details. That's the third complaint from me. Because this UI simply tell me everything's fine, right? Then let me SSH to UDM Pro to find it out. Let me simply check whether we even have BGP-D running. Nothing. Why? Because the file is not a valid configuration file. Of course, the BGP daemon will refuse to run, right? But the UI doesn't tell me. Okay, so enough about the complaints. Let's seriously start a testing. As shown in the diagram, for this autonomous system 1, I have only one gateway, one router, UDM Pro. For the UDM Pro, if I go to network settings, you can see I have 3 VLANs defined. During this video, I'm going to allow these 2 VLANs, 66 and 99, to be accessible from the autonomous system 2. And then in the lower part for the EFG, if I go to network setting, I have similar situation, but I only want to open the access to VLAN 88 as shown in the diagram. I'm using these 2 autonomous systems to simulate 2 sites in real world, so they are supposed to be connected using internet. But in my case, they are all behind my main gateway. From their one perspective, they will also have private IP address. But it doesn't matter as long as these 2 IP addresses can communicate with each other, it will simulate the internet access. So let's validate the one IP address first for UDM Pro. Yeah, you can see I have 2 WAN ports. They are both active, and the primary WAN part has the .2.100 IP address. Then for EFG, I only have the primary WAN part active, and the IP address is .2.160. So now we are ready to configure BGP. To understand how BGP works, let me run this Wireshark. You can see I already have a filter defined here. So the reason I need the filter is this Wireshark is going to capture the one side packets for these 2 gateways. Basically, this part is just to filter the traffic between these 2 one IP addresses. And then I add a TCP. The reason is I want to filter out those noises. For example, the UDP packets for Ubiquiti's device discovery. So they are not relevant to this video. In this way, I'm only going to show you the ones we are interested. Okay, having said that, let me start capturing. At this moment, nothing's happening because we haven't configured the 2 sites yet. Let me start from site A, start from the UDM Pro. If you remember earlier, we configured a ridiculous site. It didn't make sense. That's why it didn't work, right? So let me click on it. Let me remove this dummy configuration file. Then let me upload a new one. So this time I'm going to use a valid configuration file for the first autonomous system, the first site. And later, in the second part of the video, we are going to dig deeper to understand what's inside the configuration. But for now, let me simply select it. And before clicking apply changes, let me do similar thing in the autonomous system 2 in the EFG. So let me name it site B and choose a device. Here you can see I can not only select EFG, but also the 2 ECS aggregations. You may know ECS aggregation switch uses Sonic as operating system and is very powerful. It supports BGP, by itself. I'm going to have a dedicated video about ECS aggregations BGP configuration. In this video, let me select EFG. Okay, then in a similar way, let me upload a configuration file and let me select site B. Now I'm ready. Let me apply changes in both sides. You will see some packets will appear in the Wireshark. So let's try to understand what happened. The very first packet was sent from .100 to .160 from UDM Pro to EFG. And you can see it's TCP. The target port is 179. This is just the very first packet for the two devices try to establish a communication. So this is just a TCP SYN packet. But see what happened after that? All of them are retransmission from 100 to 160. Again, and then later you find another direction which is sent from 160 to 100, but similar thing happened, multiple retransmissions. So we can see from both sides, they are trying to reach out to the other side, but none of them was successful. Why? Because we are talking about one. From internet, they try to reach out to the gateway to port 179. By default, of course, it's prevented by firewall. So then we have a first problem. We need to change the firewall. So I will leave this Wireshark up and running. Once we change the firewall, you can see the situation will be different immediately. So let me go to UDM Pro first. Go to firewall. Here we are talking about from external to gateway. Think about it. For the UDM Pro, the traffic is from the internet to the gateway itself. That's why we are talking about this particular cell from external to gateway. If I click on it, I already have a firewall policy defined. For now, I disable it. So let me show you what's this one. It's from external to gateway, and the source part can be any, but the destination part, I want to be very specific, BGP, which is 179 port number. And only select TCP because BGP use TCP. Of course, the action is allow instead of block. Yeah, that's it. You can see now it's at the top of the firewall policies, which is good, but I need to enable it. Select it, resume. Okay, done. Then in the same way, let me go to the firewall for EFG. Go to the same cell from external to gateway. Then enable the similar firewall policy I already defined, which is to allow BGP. Resume. Done. Let's go back to Wireshark to see what happened. Let's start from this packet. From 160 to 100. The next one is TCP acknowledge. It's different, right? It's the first time we see a acknowledge. Why this time is acknowledge? Because EFG tried to communicate with UDM. Remember, we changed the firewall, but we started from UDM. So the UDM Pro's firewall was first changed and it allowed BGP, right? That's why from EFG to UDM Pro, it was successful the first. Okay, so the second packet means the TCP connection is established. Then see what's the next one. The third successful packet, it's a BGP already. See, from EFG to 100. Why? Because previously the handshake was successful. Move on to next one. This time it's another direction. It's from UDM Pro to EFG. Again, there was multiple resend. Why? Because at that particular moment, I didn't activate the firewall changes in EFG yet. So at that particular moment, from UDM Pro to EFG, it was still a failure. But at the same time, from EFG to UDM Pro, it's already successful. It already sent out the first open message. Then see what's going on later. See this one from EFG to UDM Pro. It's a BGP keep alive message. It's just simply like heartbeat to keep the BGP connection alive. And then later you can see another BGP packet again from EFG to UDM Pro. See, it's a update message. See what's the update? In the update, it includes all the path information. Finally, we see the exchange about routing. See this section? It has the subnet 88, which is from the EFG, right? So in this packet, EFG notified UDM Pro, okay, I have a subnet, you can route to it, okay? And then see what's the next one from UDM Pro to EFG. It's another update message, but because this time it's from UDM Pro to EFG, see what's the difference in the packet content. In the second section, you will see at this moment in the configuration for the site A, I only allow the subnet 66. That's why in this packet, you only see this subnet 66. So UDM Pro told EFG, okay, I have a subnet, you can update your routing information. And then later we can see the keep alive information, right? Because starting from the second update message, there was no network configuration change in either of the sites. So the only remaining BGP packets were keep alive. Right after we enabled the firewall policies in the two gateways, BGP was successfully established. So this is what we can observe from the Wireshark. Before moving on, let's revisit the firewall policy we created to enable BGP. For example, in the UDM Pro, let me click on it. The source zone, yes, it's external, but we made it too wide. Now it allows any IP address. Apparently it's not safe, right? So let me make it right. Let me select IP, and here I need to specify the router 1 IP address from the other side, the EFG's 1 IP address. So this is what I need to put. Okay, click add. That's it. Apply changes. Then for the EFG, I need to make the similar change. This time I need to specify the UDM Pro's 1 IP address. At this moment, we are not done with firewall yet. You will see why. Let me open two Linux terminals from each site. Let me show their IP addresses. You can see the left side one, it's in VLAN 66. It belongs to UDM Pro. The right side one, VLAN 88, is part of the EFG. I assume the connection should be possible. So from the right side one, let me ping the left side one. Okay, ping it. It doesn't work. There can be many reasons for the ping's failure. So let me SSH into the two gateways to understand whether the routing even works. Okay, I'm in the UDM Pro. Let me run IP route. I see the expected default network, the 2.1 parts, and then VLAN 66, VLAN 99, right? And this one for VLAN 88, that's the result of BGP. You can tell from here. What it's saying is if you want to reach out to this subnet, you need to go through this one part with this IP address. This one part is on UDM Pro. This IP address is the one IP address of EFG. Then run the same in the EFG SSH. In the exact same situation, the special part is this particular one. So if you want to reach out to VLAN 66, you need to go with this one part of this EFG, and to reach out the other side one part IP address, which is .2.100. This is the UDM Pro's IP address, right? So from routing perspective, I don't see any problem because the BGP was successful already. Then why this ping doesn't work from the two clients? The only thing I can think of is firewall rule. Someone may ask, hold on, you just created a firewall policy, right? It's from external to gateway, and it's called allow BGP, and we allowed TCP part 179, right? So why here we are talking about firewall policies again? Let me explain that. What we just did in this particular firewall is just to enable the BGP. And the BGP is used to exchange the routing information between the two autonomous systems. Once the BGP is established, whatever following routings between your networks, they will use their whatever proper protocols and ports. They will not use TCP port 179. So don't confuse yourself. The real traffic will be between this one part and this one part. That means to make this traffic possible, we need other firewall works. I need to understand which existing firewall policy prevents the traffic between VLAN 66 and VLAN 88. To do that, in the UDM Pro's SSH, let me go to var log ulog folder. There is this file called syslog.mu.log. It's internally used for syslog by UniFi Gateway. So let me run the command tail and specify this file. Then it will reflect the changes in real time. Then in the right side, let me do the ping again, but let me only do it once. So the ping still fails. In the left side, nothing's displayed. Why is that? Because the firewall policy, which prevents the traffic, is standard default firewall policy. Or the default firewall policies, they won't write syslog if you don't change it. What I need to do is to find the firewall policy which I'm interested in and flip on the syslog. Check the diagram. What we are talking about is the traffic from 88 to 66. But from the WAN perspective for these two gateways, the traffic is from the WAN of the EFG to the LAN of the UDM, which means from the zone-based firewall, what I'm interested in is the cell from external to internal. That's the cell I want to focus on. Let me click on it. You can see all the existing firewall policies. They are default ones, right? And apparently, if there's any firewall policy which drop the traffic, it must be this one. Block all traffic. Click on it. Enable syslog. Apply changes. Then let me redo what I just did. From the right side Linux client, ping the left side Linux client. We got one syslog generated. This one will tell us a lot of useful information. Let's see this one. In the square brackets, it confirms the zone information from WAN to LAN. WAN and LAN, they are just internal names for the existing zones from external to internal. Then see which particular firewall policy is called block all traffic. That's exactly what we changed, right? Then see what's the source IP address, the WAN IP address of the EFG. It is not the VLAN 88 IP address. Why is that? Because the packet is netted. It went through the net done by the EFG. That's why the internal LAN IP address is changed to the WAN IP address. And then see the destination. The destination, it is still the LAN IP address of the UDM Pro. It is not the WAN IP address of UDM Pro, because from EFG perspective, it doesn't care where is the target as long as it has the required routing information. It's fine already, and it doesn't need to know the target subnet. It need to go through net, right? So just want to explain this seemingly strange source and destination IP addresses. So we confirmed the troublemaker is this existing firewall policy, right? Then to resolve it, that's easy. We simply create a new policy, and then I will say allow ICMP from site B, and then see the source zone, it should be external, right? I need to specify the IP address. You can tell from the syslog, the IP address is the WAN IP address of EFG, which is this .2.160 IP address. So let me add it, click add button. Then for action, I want to allow. For destination, it should be internal. Here, I want to specify network. For now, I only open up the VLAN 66, right? So let me select VLAN 66. For now, I only want to allow the ICMP. To select ICMP, I need to first change the IP version to IPv4, and in custom, let me choose ICMP. Let me specify any for ICMP type. Add it, and the order is also correct. It is the first one. Then let me redo the ping one more time. Okay, see, it is successful thanks to this new firewall policy. Of course, to make the setting complete, I need to create a similar firewall policy on EFG, right? But it's in the exact same way as the UDM. So for this video, I will skip that part. Before I move on to the second part of the video, let's revisit the user interface. Just from this UI, You don't know whether the configuration file is valid. You don't know whether the BGP connection is established. You don't know whether the routing information is exchanged. You don't know whether the traffic will go through. You know nothing. It doesn't tell you anything. I'm so surprised Ubiquiti calls this a released functionality. What I expect is it should have detailed configurations, and then it should have a pause, resume button, and if I want the BGP to be established, the system should automatically handle the firewall policy to open up TCP 179 port. And then it should give me the runtime, real-time statistics about the communications between the networks for these two autonomous systems. Only after that, you can say, okay, this gateway support BGP, not like the current situation. Okay, let's move on. In the second part of the video, let's dig deeper, looking into the configuration file to relate the configurations with the backend implementation in UniFi Gateway. In fact, BGP in UniFi Gateway is implemented using FRR. FRR is very popular, it's free, open source, and it supports multiple very important routing protocols such as OSPF, RIP, and BGP. In this SSH for UDM Pro, I can run VTYSH. Now I'm in the console for FRR. I can run a lot of BGP related commands to check the configuration and to check the current status. And then in the lower left, I show you the site A's configuration. For site B, it has very similar configuration, so I'm going to use site A as an example. The first line, router BGP, this line specifies the ASN or autonomous system number. Because this is my lab environment, I need a private ASN. In this RFC 6996, you can see you can name your private autonomous system with a number in this range. That's why here I say 6500. It's just a number I choose. Then the second line, it specifies the router ID. And this is router ID I use. In fact, it's just a name. It's just a string. You can use whatever you want. But here, just for easy understanding purpose, in my particular case, I use the one IP address of this particular gateway. And then you can see this exclamation sign, which means it ends a section. What's this section? For BGP process configuration. And the next section is about network advertisement. You can see here, I'm advertising this subnet. As mentioned in previous diagram, for UDM Pro, for this AS1, I want to advertise VLAN 66 subnet, right? So that's why here for network advertisement, I specify this subnet. In fact, this is the information we saw in Wireshark in the BGP packet for update message. So the UDM Pro will send this subnet information to EFG because it is supposed to be advertised. Then the next section is about BGP neighbor definition. You can see here for this UDM Pro, its neighbor has this ID. This is for EFG. And here I provide the ASN, the autonomous system number for the EFG's site B. Okay. And the second line, simply give it a description. After this section, the UDM Pro already knows the basic information of the other side. So in the right side FRR console, let me run the command show BGP summary. Here you can see for the UDM Pro, it has a neighbor with this ID, exactly like what we specified in the left side configuration. This is the BGP version. This is the ASN for the remote autonomous system. And here we have some statistics about the BGP packets sent and received. And then here we have the up-down time. Here we have the prefix information. In BGP, a prefix is a shorthand way to refer to an IP network or subnet. Typically in CIDR notation, it represents a block of IP addresses that is advertised. You can see here we see prefix received 1, prefix sent 1. Why? Because the received one was from EFG for VLAN 88 and the sent one from this UDM Pro for VLAN 66. Now move on. The next section is about IPv4 specific settings, about how the two autonomous systems will exchange the routing information. Let's see what's configured. The first line, the neighbor for the EFG, activate. So without this line, the BGP session between the UDM Pro and EFG will not even start. So this is important to make the BGP possible. And then the next line is to say, okay, between this UDM Pro and EFG, the soft reconfiguration inbound. It enables soft inbound route refresh without resetting the BGP session. In the other side, site B, I have the similar setting. So remember, we mentioned the end picture for site A is I will have two subnets advertised, right? But so far, we only enabled VLAN 66. So later, we will have a short testing. We will add VLAN 99. You will see without restarting anything, the routing can be automatically refreshed. That's what this soft reconfiguration inbound means. Okay, then the next two lines, it is referring to the so-called route maps defined later. See these lines? They will define the route maps. They are referred in this IPv4 configuration. These two lines control which routes you accept and install in your routing table. Later, we will discuss these two so-called route maps when we are there. Okay, the section is the IPv4 part to control how the routing information can be exchanged. Now let's talk about route maps. As we mentioned, these two are definition of two route maps. In fact, a route map, it is a policy filter. It defines in BGP for inbound and outbound routing information exchange, how it works, what is allowed, what is not allowed. The route maps will refer to prefix list as well. So to better understand the prefix list, route maps, and this IPv4 three different sections together, let's do this way. So let's first understand the inbound, so which is defined here. For inbound from the EFG, it will apply this route map. The name is accept routes. To see the definition of accept routes is here. Basically, the action is permit, and it has a sequence number 10, just like in your firewall. For different firewall policies, you have a sequence number that will determine the order, right? In the same way, for route maps, you have different sequence numbers. But because in our case, it's very simple, many times you only see one sequence number. And then see what's this route map details. It will match the IP address defined in this particular prefix list. The name is accept all. The accept all is defined here. So what's accept all? It simply says permit any. So that if you read this first green line, this first black line, and this blue line, what it really says is for UDM Pro, for inbound routing information from EFG, the UDM Pro doesn't have any limitation. It allows all. Whatever EFG tells it, it will accept it. That's what these three lines mean if we read them together. Okay, move on to the outbound. See, for outbound, it will use this route map. It's called advertised routes, and it's defined in the second black line. It says as long as it match this particular pre-list with name advertise specific, and this prefix list is defined in the second green line, which simply means this subnet. So if you read these three lines together, what it really says is for UDM Pro, for outbound routing information, it will send out this particular subnet. Okay, I hope now it's clear, right? It's a little bit difficult to understand if you read them separately. These three sections, they are related to each other. In the lower part FIR console, we can run some related command. For example, I can run show route map. It lists everything we just discussed. See, for BGP, it has these two route maps. Before ending this video, let's do a quick testing. Let's add VLAN 99 to the advertised network in site A in UDM Pro site. To achieve that, we need a slightly modified configuration file. Let me show you. Let me only talk about the difference. See this line, I have a new network defined for VLAN 99's subnet. And then the next difference is here. I have a new prefix list. I will permit this particular subnet, right? And see how this one is related to the existing one. The existing one has the sequence number 5. The new one has the sequence number 10. That's how these two are differentiated. So from the UniFi network controller for UDM Pro's BGP configuration, let me remove the existing configuration file, then upload the new one. Okay, apply changes. Remember we mentioned we specified soft reconfiguration inbound for both UDM Pro and EFG, and the UDM Pro's configuration change to EFG is inbound, which means for EFG it's a soft reconfiguration. So let me apply changes. Now the change should be active. Let me confirm that in the FIR console. Let me show the IP route information. So this is in the UDM Pro side. Of course, the VLAN 99 subnet is here, but this has nothing to do with BGP, right? To see whether the change is really effective, I need to go to the SSH session for EFG. Now I'm in EFG. Let me run VTYSH, then show the BGP summary. It received 2 prefix. This is a good sign, right? Because that means 2 subnets information were received. And you can see the up-down timer is reset because even though EFG doesn't need to restart anything, the UDM Pro does need to resend all the prefix information, right? So that's why here you see the timer changed. If I show the IP route, okay, I see VLAN 99 here as well. It was not here. And you can see to reach out to VLAN 99, it needs to go through the Ethernet 2 and reach out to this IP address. This is the UDM Pro's one-part IP address, right? Okay, so this confirms the new advertised network from UDM Pro has been successfully received by EFG. Then the very last small demo is about password. So you may realize for these 2 example autonomous systems, for the configurations, I didn't specify password, which means the only protection I have is the firewall for TCP port 179. So you may want to enhance it to make it more secured. The password setting is very simple. Basically, you need to specify the same password in both configurations. Let me show you. In the site A configuration for UDM Pro, let me add this line. So I specify the password in clear text, but the actual password is used for TCP MD5 signatures on the BGP TCP session port 179. If you want to know more, you can read this RFC 2385 for protection of BGP sessions via the TCP MD5 signature option. So this is for site A's configuration, right? So if I save it, then in UDM Pro, I remove the current one, upload the new one, apply changes. I expect the BGP session to fail. The reason is I only updated the site A's configuration. So let's see whether it will be the case. From the EFG's FIR console, let me run the command show BGP summary. Now the state is connect, but it will stay as connect. It will never finish, which means the BGP session won't be successfully established because inside B's configuration, we don't have the password specified yet. So then let me move on to specify the password in site B's configuration. Then let me paste the exact line I used in Site A's configuration files. And apparently, I need to modify this ID to match the UDM Pro, right? Change it. But for password, I need to keep it the same. Then save it. Then from EFG's BGP configuration, let me remove the existing one, upload the new file, apply changes. Then from the FIR console, let me run the exact same command, show BGP summary. Okay, see what's the difference? It's connected, 2 prefix were received, 1 prefix was sent. Now everything's okay. Now these 2 sites are protected by password. Okay, this ends the video. Thanks for watching.